Hello everyone, today in this video we are going to make Neo 6M GPS based speedometer using the Arduino UNO. So let's get started. Now let's understand the circuit diagram. This is the Arduino UNO. This is the U-Blox Neo 6M GPS. This is the LCD display right here. So first of all, let's understand the GPS side connections. So the RX pin is connected to digital 6th pin of the Arduino UNO. The TX pin is connected to digital 5th pin of the Arduino UNO. Then the VCC pin is connected to 3.3 volt. The ground pin is connected to ground of the Arduino. So this was the GPS connections. Next, understand the LCD display side connections. So the VCC pin of the LCD display is connected to 5 volts of the Arduino UNO. The ground of the LCD display is connected to ground of the Arduino UNO. Here, in order to control the contrast, we have connected the wiper side of the potentiometer to the contrast pin of the LCD display. Then we have connected the other two terminals of the trim pot to the VCC and the ground. Next, the RS pin of the LCD display is connected to 12th pin of the Arduino UNO. The enable pin of the LCD display is connected to 11th pin of the Arduino UNO. Then D4, D5, D6 and D7 is connected to digital 7th, digital 4th, digital 3 and digital 2 pins of the Arduino UNO respectively. The LED plus pin is connected through a resistor to the VCC of the LCD display, and the ground of the LED is connected to ground of the LCD display. So this was about the circuit diagram. Now let's understand the code section of our project. So first of all, I am including the tiny GPS++ library with which we can easily get the data such as longitude, latitude, altitude and speed from the GPS module. Next, I am using the software serial library in order to use the other digital pins of the Arduino for the serial communication. Next, I am using the liquid crystal library in order to run the LCD display. Next, I am declaring the respective pins, that is RX pin and TX pin, for serial communication on the Arduino. Next, I am declaring an object for tiny GPS plus class. Next, I am declaring an object for software serial in which I am passing the values of RX pin and TX pin. Next, I am declaring the pins of LCD display. Here I am declaring an object for the liquid crystal and passing the values of pins of the LCD display. Next, in the void setup, I am initializing the LCD display using the .begin function. Here I am passing the number of rows and number of columns. Next, I am initializing the serial communication using the .begin function of the software serial library and setting the baud rate to 9600. In the void loop part, if data is available to read from the GPS module, then this while loop executes. If there is no data to read or available to read, this while loop will not execute. Next, here using the ss.read, I am reading the data from the GPS module and encoding it using the .encode function of the tiny GPS++ library. Next, using an if statement, whenever the data is updated, this if statement executes and it prints the value, that is the speed in km/h with a precision of 1 digit on the LCD display. Now let's test our circuit. So here you can see this is the LCD display, this is the GPS module right here, and this is the Arduino UNO right here. On the LCD display you can see that we are getting the speed in km/h. Now we are at rest, so the speed is 0.0 km/h. Now in order to test the project, I am just carrying the whole project and I have started walking. So on the display you can see that we are getting the speed value in km/h. So the display is showing the speed with which the GPS module is moving. We can use this system in vehicles such as four-wheelers and motorcycles. The advantage of the system is that we don't need any connection with the wheel in order to measure the speed. We can measure the speed wirelessly using the GPS module. So this was about the project. I hope you have liked it. Thank you very much.